Hi. Now is the second part of section 1.6, logarithmic functions. In part 1, we did how to find inverse of f. So once fx is given, then we write y equal fx, and we now solve for x so that x equal a function of y, and here exchange x and y so that it becomes now it becomes here y equal function of x. That is basically here now f inverse of x, right? We did in the first part. And also we recall exponential function fx equal a to the x. This function is either increasing or decreasing. So it is one-to-one, and it has an inverse function. Now, as an inverse function of an exponential function, logarithm function can be defined. But before this definition, let's try to solve this example. Okay, start with y equal 2 to the x, and let's try to find the inverse of the function. Now, first step of finding inverse is solving for x. We have to solve it for x, but it is not elementary operations like addition, subtraction, multiplication, and division. So that now, in a sense, symbolically, we solve it, and so that we introduce a symbol log along with base 2, and this portion will be here now is a function of y. So log, that one is a sort of a notation or some symbol for just so that eventually when it is solved, this equation is solved for x, then the result, it is representing the result as a function of y. And we may consider that. And the second step of finding inverse is exchanging x and y so that we reach it over there. So log 2 of x is inverse of 2 to the x. So here, y equal 2 to the x graph is given in this way, so that y equal log 2x graph must be the reflection with respect to y equal x. Now we'll go back to the definition. Once the logarithm function with base a, then we write in this way, but that is defined as an inverse of y equal a to the x, so that here y equal a to the x means that ay equal x. So it is a kind of a solving for x. Okay, that changes solving for x. So logarithm can be considered as some notation or symbol for solving for x of that function. Okay, now here, if you consider the domain and range of a logarithm function, then quite simple. And y equal a to the x, that admits the whole real number, and the range of this exponential function is from 0 to infinity, to larger than 0. But inverse is a logarithm function, so that now the logarithm function is not taking this one as the domain, and now taking r for the range. So here domain must be positive numbers, as you can see from this picture, log of 2x is taking only positive numbers. So it is domain. And also, log of 2, 1, x is 1, then the value is now 0. Okay? Okay, here, once the base is e, then log ex will be written into this way, ln x. Yes, that is natural logarithm, and NLL, and L. But that one is not easy to deal with in some environment, so that people change this at an n, so that eventually we have ln. Okay, now, and once the base is 10, then we may ignore this base, and it is called the common logarithm. If you are using calculator, then you can see ln and log. ln is representing natural logarithm, and log is representing the common logarithm. However, if you are using computer and computer programming, then you can use log for natural logarithm and log 10 for the common logarithm. So you have to be a little bit careful. And computer programming, natural logarithm is can be called by using log. Okay, here we have properties of logarithms, and here that multiplication can be separated into log ax and log ay, and also division with a subtraction here, and power can go in front of the logarithm, and 1 over x, that is a special form of that one. Anyway, among this one, let's try to prove the first one. Okay. Now, okay, yeah, let's begin with it this way. Now, let's say that is p equal log a xy, and q is now log base a x, and r is log and base a y. Let's say in this way. Then, from the definition, it's the same as now a to the p must be xy, and now a to the q is x, and a to the r is here y. So from these two, if we try to multiply, then we can get here now a to the q plus r is same as x and y. This is x and y together the same, so we can conclude here now a to the p is same as a to the q plus r, the same base, so that the exponent must be the same, p equal q plus r. We start with this is p, this q, this is r, then we end up with this one is same as the addition of these two, which is exactly same as that one. Similarly, you can prove the others, and by some other technique, you can get easily prove these identities. Okay, this is inverse properties, and a to the x and log base a of x are inverse each other, so that here this can be cancelled out, so it is x. Now here, okay, now also the same, log base a and a to the x inverse each other, so that cancel out. You may think this way, or now yeah, this power can go out, so x now log base a and a, so that is 1, so that it is x. Okay, let's see here log a. We want to try to figure out what it is. Okay, so that, let's say this is y. Then from definition, the same as ay equal a. That a, the small a is here, and that a is this one. And so that for a and y power is a, that means that a, okay, not a, that means that y must be 1, right? Y must be 1. Okay, in this computation, we try to find this value and we named it using y. Now y is found, which means log AA for any a, log AA is always 1. Okay. Now here, that is natural logarithm base e, and so it is a special form of this one. It's a special form, and e to the x and natural logarithm of x are inverse each other so that it can be cancelled out. And also the same logarithm e to the x can be cancelled out to become x, so that this one is a special form of this one. Okay. Now we want to use lots of logs to expand this logarithm. Okay, this is a natural logarithm, and so from now on I'll try to use G notation, which means that given term. So this means this given whole term. Okay, we'll do step by step. And now natural logarithm and numerator x squared and square root of and x squared plus 3, and denominator along with the negation natural logarithm and 3x plus 1. We use the formula over here, that one. Now we'll try to use here now that power rule and product rule, quotient rule, power rule, and reciprocal rule anyway. Okay. One more time, we'll try to use product rule. So there's a logarithm x squared and plus natural logarithm and square root of x squared plus 3, and here natural logarithm 3x plus 1, right? Okay. Now let's try to use power rule. Then 2 will go out and logarithm x, and there's half power go out and natural logarithm x squared plus 3. And simply we put the same. I guess now it is expanded. We have done. Okay. Now we'll try to simplify these terms. Okay. Now for a, the given term can be written in this way: log base 3 75 minus these 2 can go as power, so that logarithm base 3 and 5 to the 2, so which is same as 25. So here now by using quotient rule, log 3 and then there is a 75 on the top, and bottom that is same as 25. So the fraction is 3, so that it can be written now log 3 to 3. Earlier we already know that log AA is always 1, so that this value is 1. That is the final answer for part A. Now let's go to part B. Okay, the given terms can be written in this way. Okay, the power, we'll try to put a power, or you can put 2 outside and only, and power 2 can go up. Various ways you can do that, but we'll put everything over there, so that the first term can be changed into log base 5 10 to the 100 to the 2. Okay. Now subtraction along with log and 5 and here 50 to the 4. Of course, over there you can change this one as 10 to the 4. You can do that if you want. So that, okay, let's do that. So that log 5, and that is now here, okay, 10 to the 4. And so that, and by using quotient rule, you can get that is 10 to the 4 divided by 50 to the 4. Okay. Now, let's try to focus on this term momentarily. And that is same as now, this is 1 over 5, the ratio to the 4. Right? So that is the same as 5 to the minus 4. So here, this term is same as log 5, 5 to the minus 4, and minus 4, the power, by using power rule, minus 4 can go out, and log base 5 at 5. So, but this one is always 1. Log AA is 1, so that the final answer will be minus 4. Quite easy, right? Okay. Now, let's try to solve this for x. Okay. Now, x is here, so that, okay, let's try to write down a here now. X is here, so that we have to eliminate that one. How? Apply logarithm function, natural logarithm function. Then, for example, here now, natural logarithm e to the 5 minus 3x, and the same as now natural logarithm of 3. And this equals same as that one. We apply the natural logarithm both sides, so it will be the same. Now, yeah, natural logarithm and e, that functions are inverse each other, so that we have 5 minus 3x, which is same as now natural logarithm of 3. So here we are moving this one in the other side, so that we have 3x equal here 5 minus natural logarithm of 3. And so that we can conclude here now x equal 1/3 of 5 minus natural logarithm of 3. Okay, this is the final answer for A. Now let's go to B. Okay. Now for that one, the same A, okay, the base are the same, so that we can use product rule. So that is the left hand side will be here log of base 3 and x times x minus 2. Okay, now that is 1. So that we may try to apply here now 3 to the x both sides, then that will be this here. However, rather than that, we try to change this one base 3 logarithm, so that log 3 log AA is always 1. Now we can here cancel both sides log 3 base. Then we have here x, okay, x here and x minus 2 equal 3. Okay, now it becomes a quadratic function. So x squared minus 2x minus 3 equals 0. And this is x-x separation. There's 1 and 3 separation. It must be negative. It must be positive. That means here this quadratic equation can be written here, x plus 1 times x minus 3 equals 0. So we can get here now x equal minus 1 and x equal 3. We have two solutions. However, now you have to be very careful. You have to check if they are in the domain. Okay. Now, from original equation, Okay, let's try to use red pencil. Now, the domain must be, okay, logarithm is admitting only positive values. So from here, x must be positive. From here, now x minus 2 must be positive. Altogether, x must be larger than 2. So that is, in a sense, domain for the left-hand side. So x must be larger than 2. So x minus 1 cannot be the solution. So we exclude this one, and that is only the solution. Okay, you have to be very careful when you combine them. But that means that once x is minus 1 and both sides, this value is negative, that is negative, but after product, it can be positive, so that after, okay, we are solving this part, so that after multiplication, it's okay, but separately, it's not, so that you have to be really careful. Okay, now the final part, C. Okay, now logarithm and logarithm x, that is 0. That means that this must be 1. So let's say here now, let's rewrite that's 1. And so that is no logarithm of base e, so that x must be e. Or out of that one, you can say that if you are applying the natural exponential function, then e to the logarithm x equals same as e to the 1. And now this portion will be cancelled out, so the x equals e to the 1, which is e. You can do either way this problem. Okay, here we have claim. Every exponential function means that every exponential function of arbitrary base is a power of natural exponential function. And okay, this can be gotten, here the proof is given, a to the x is same as now e to the natural logarithm a to the x, because they are inverse each other, is the same. And here, after that, now if we are focusing on this portion, then this is by using power rule, x can go out here in front of a logarithm. So we reach at that is exactly this equation. Now, and every logarithmic function is a constant multiple of the natural logarithm. Okay, so that we have this form. Let's try to consider first the proof. Then we start with a natural logarithm. Then now x can be written here now a to the x and log a. So this portion are identity, so the same as this one. And then now if you are considering now from this one whole thing, then log a, and then this one is a sort of a power, so that by using power rule, it can go in front of the logarithm. So that is exactly this one. And here, divided by logarithm a, natural logarithm a, makes that one. This one is called changeable base formula. If you are using computer or calculator, then you can get the function available are, for instance, in computer, and log for natural logarithm and log 10 for common logarithm. Except that no other base logarithm can be computed. However, if you are using this formula, then to get for general A, you can use this formula so that you can compute natural logarithm of x and natural logarithm a and by measuring the ratio, you can conclude the value. So even though only these two are available, no problem. In fact, only one, even though it's only one is available, no problem. But the log base 10 is used in some cases a lot, so it's called the common logarithm. Our number system is base 10, so that's the reason this one is commonly used, so that we have some extra logarithm function. But even though we have one, really no problem. Okay, this is end of the section. Thank you. I mean part 2, and thank you.